Okay, we're going to take a look at the Mayan mathematical system. It's really kind of interesting. It's a base 20 system instead of our own base 10 system. And what you really need to know is that 1 is a dot, 5 is a horizontal line, and 0 is this beautiful thing. I'm sure that maybe an ear of corn or something. It's going to be written in here, and I encourage you to read it. Now, what does a base 20 numeral system mean? It means that, it means that there are 20 distinctly different characters for the numbers. So 0 is the symbol here, and the interesting thing about the 0 is they are one of the only ancient cultures to discover 0, which for you and I seems laughable, but back then it was something they didn't know about. 1 is a dot. 2 is 2 dots, 3 is 3 dots, 4 is 4 dots, 5 becomes a bar, 6 is a dot over bar, 7, 8, 9, and then 10 you have a bar. And that pattern continues all the way up to 19. For 20, they're going to have another place value. So in our system, when we get to 9, we have to add a new place value, the tens place. So we have 1 10, 0 ones. And we continue that. So for this number, we have 200, or 2 100s for 200. We have 2 10s for 20, and we have 3 ones. And you add those together, and you get 223, right? So that's basically how our system works, and their system works in the same basic principle. The only difference is they have 20 characters instead of 10. Well, what does that mean in practice? Well, here's what it means. They, instead of using horizontal place values, they had vertical place values. So the bottom is just the ones place. The one above the ones place is the 20s place. So whatever number is here, you're going to multiply by 20 because it's the 20s place. Your third digit is going to be the 400th place. In other words, 20 times 20, which is 400. Your fourth place value is 8,000, then 1,600, or sorry, 160,000. I misspoke there. And you can continue this forever just by multiplying 20 for each place value. It's the same basic principle that we had. So if I were to take a look at, say, this one here, I have 2 groups of 8,000. So what is 2 groups of 8,000? That would be a whopping total of 16,000. I have 3 groups of 400. 3 times 400 is 1,200. I have 1 group of 20, and I have 19 ones. So you add them all together, and you get 9, 3, 2, oh, there's a mistake on this one. And then 7, 1. 17,239. Because 2 times 8,000 is not 8,000, it is 16,000, and we all make typos from time to time. So that's basically how it works. It's a lot easier to go from Mayan numerals to Arabic numerals. So if I take a look at this problem, I just take what's in here, multiply it by the place value, and add it together. Simple. It's far more difficult, but not really, to go the opposite way. So if I have 1999, like most of your birthdays, actually, since we have this example and you have this example, I'm going to come up with a new number altogether. So I'm going to come up with, oh, I don't know, let's say 2,345, really original number. So the first thing I'm going to do is, are there any 8,000s that go into this? No. So how many 400s go into this number? So what I'm going to do is I'm going to take my calculator, and I'm going to say 2,345. I'm going to divide it by 400. So five of them going, right? So that means 5 times 400 is 2,000. So I'm going to subtract out that 2,000, and I'm going to trade it in for 5, just a flat bar, for my first place value. So I go ahead and subtract it out. So I get 5, 4, 3. So how many 345s can 20 go into? How many times does 20 go into 345? So I'm going to divide this by 20. I get 17. So 17 is going to be 3 bars with 2 dots. So 17 times 20 is 340. Subtract it out, and I get 0. I get 5 left over. So in my ones place, I have a bar. So in other words, 2,345 is equal to bar, dot, dot, bar, 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 bar. And there is my Mayan translation. Ta-da!